Dear students, on the application of chi-square test, we were discussing about the values which were obtained from genetist Mendelian, and he has given the growth of garden pea seeds in the form of round and yellow, wrinkled and yellow, round and green, wrinkle and green. What we do here, theory give certain values and the prediction according to the proportions are in the form of 9:3:1, and what are the new frequencies using this formulation, and then how this chi-square test equation behaves, whether the relation between theory and the fact, whether it is to be accepted or it is to be rejected. Let us see how these mathematical calculations will go for the application of chi-square test. That is, already I had reminded you about chi-square. The equation says observed frequencies, summation of observed frequencies minus expected frequencies whole square divided by, that each value will be divided by expected frequency. Now how to calculate, that is the total of the given frequencies. When he was conducting the experiment, then in one of those experiments, the following values which we got as round and yellow total as 315, that is 101, that is round and yellow we get 315, round and green that is 101, this is wrinkled, and round and green, that should be 108, wrinkled and green, that is 32. When these are the results from one experiment he got, and we will take this as total as 556. This is nothing but sigma f, and we call it as, that is, observed frequencies. Then what is the theory says? That theory says the proportion is 9:3:1. This makes the total 16. Now what we do, how this equation we are going to apply, and then to conclude whether the hypothesis which we are going to propose, the relation between theory and the fact is going to be accepted or not. It will be done like this. Each frequency, that is 315, 101, 108 and 32. Against these values, new frequencies we have to generate. How to get new frequencies? That is, for the first one, if you take, that is 9/16 multiplied by 315, that is 16, and 3/16 multiplied by 100, like that we calculate, and then that is 9/16, and then some kind of values you are getting. Then if you make the total of it, for example 9/16 into 556 and 3/16 into 556, that is 3/16 into 556, and that is 1 divided by 16 into 556 respectively. We are getting the values 313, then 104 and 35. That means in place of 315 I am getting it as 313, in place of 101 I am getting it as 104, and in place of 108 I am getting it as the same thing. Then and in place of 32 I am getting it as 35. Then these values are numerically approximated because 313, 104, 104 and 35 may not be the whole numbers, they may be in terms of the decimal values. Then what we do here, something for example like 312 point something or 103 point something, 103 point something and 34 point something. So we rounded off these numbers and we were able to write like 313, 104, 104 and then 35. Now these values we call them as expected frequencies. These are the observed frequencies, these are the expected frequencies. Yes, whether there is a relation between these two, that means theoretically these values, this is from theory and this is the actual fact. What we do here according to the chi-square test, we will verify whether any relation exists between theory and the fact. Therefore, I take this equation as, that is chi-square equation, that should be observed frequency minus expected frequency whole square, and each value will be divided by expected frequency. How you are going to write? That is, observed frequency is 315 minus expected frequency is 313. This should be made whole square and divided by, that is expected frequency, that is here 313. Expected frequency is 313 plus of, that is observed frequency is 101 minus 104 divided by 104 and numerator must be made whole square, then 108 minus 104, this is whole square and divided by 104 and plus of, that is 32 minus 35 whole square and divided by, it should be 35. This is releasing the sigma notation to write all the values which we make the correlation between the observed frequency and the expected frequency. That is first value with first value, second value with second value, third with third, similarly fourth value with fourth value. This comes out to be the value. Actual calculation is 0.51. If you make summation whole square and all that, this comes to be 0.51. What is this value? This is chi-square. We call this is the actually calculated value. Now, how many values are given? Totally 4 types of frequencies are given. Here we apply the selection of table value for chi-square using degrees of freedom. That degrees of freedom means here total number is 4 and df, in my previous lecture I told you, df is equal to, that is 4 minus 1, that means one number less, that should be 4 minus 1 is 3, and the chi-square value at 5% level of significance, you have to collect that value from the table looking to the column. In that column this against 3 you have to take, and the value of chi-square, that is at 0.05 implies 5% level of significance. That value against 3 is 7.815. That value is equal to 7.815. This is the table value. Now, from the example what we collected is and calculated is chi-square is equal to 0.51, and if you compare these two values, and chi-square value is less than the table value, and already you know that less than the table value means you have to we can accept the high degree of agreement between theory and the facts, that means theory and the experiment. That means 0.51 is less than 7.815, that is table value. Then so that is under the 5% level of significance this value appears, so that by chi-square test, this Gordon-Pia experiment, whatever these frequencies are given, that is here round and yellow, wrinkled and yellow, round and green and wrinkled and green, whatever the frequencies, that means number of seeds which in that particular experiment are obtained, have good agreement with the theory and the experiment. The students, what is the conclusion exactly from this type of situation is, whatever the experiment you conduct and collect the frequencies, and then if there is a theoretical meaning is there, and see that how that theoretical meaning goes according to the numerical values, then make use of all those numerical values with the theoretical meaning and see that which equation you can use in order to conclude which best answer that can be sample can be accepted or it can be rejected. That means this is one sample which we can collect. For example, 315, 101, 108, 32 makes us 556. This is one sample which is taken from the growth in the Gordon Pia experiment. Likewise, we will move on to another problem. A die is thrown 264 times and the number appearing on the face X follows the following frequency distribution. That means number of times head we are getting when die is thrown 264 times, number of times the numbers are going to appear on the upper surface. Numbers are going to appear on the upper surface means the number is 1, a die is thrown means you know that it is a small cube, right? It is not indicated with 0, but it starts with 1 and it ends with, that is up to 6 here. Therefore, 1 appears 40 times out of 264 times, and 2 appears 32 times, 3 appears 28 times, 4 appears 50 times, 5 appears 54 times, and 6 appears 60 times. Calculate the value of chi-square. Calculate the value of chi-square means here also you have to do the same thing, and expected frequencies will be calculated using the equation, that is how many values are given, and the common arithmetic mean will happen to be the expected frequency. That means common number will be, you have to add all these values, that means 40, 32, 28, 50, 54 and 60. Totally how many values are there? 6 values are there. You can add all these values and then get the value, that is common frequency will be there. These are the frequencies means observations. As I told you that in the basic statistics, getting one, this 40 makes us an observation, and getting the number 2 on the upper surface, that is 32. That should be as you know that it is small die means it is a small cube with 6 faces. On each surface dots will be there. Like this, up to 6 dots will be there. This implies for 1, 2, 3, 4, 5, 6. Totally 6 faces are there on the upper surface. By throwing a single die, getting 1, it must be 40 times, and getting 2, 32, and getting 3, it is 28, and getting 4, 50, then getting 5, 54, and getting 6 is 60. That is totally 6 numbers are there. It starts from 1 and it is 60. That means if you use the basic formula for probability, there also we took this as a major example, number of commonly occurred examples for defining the basic probability as tossing the coin, throwing the die, drawing the ball from different colored balls which are mixed in a bag, and playing cards also. Likewise, some good examples we have considered. Then from this die, from 1 to 6 only we can expect when you throw a single die, that is starts from 40, and this is supposed to be 264 times, means total frequency it is. Fine. Now what we are going to do is, these values are called, that is observed frequencies. Now to apply this and to give the conclusion whether these frequencies means this is in one case of an guessing, right, and whether it is correct or not, or this approximation can be accepted or not, will go through the chi-square test, then what we do here, we have to find out the expected frequencies. To arrange for expected frequencies, we go for, particularly for this problem, the procedure we can follow like this. Take the average of these 1, 2, 3, 4, 5, 6, then you will get x bar is equal to 264 divided by 6, 6 4s are 24 and 2 remains, that is 6 4s are 24. This will happen to be the common expected frequency. That means we can attach this 44 with 32, 44 with 28, 44 with 50 and 44 with 54 and 44 with 60. Then these values, that is expected frequency, because my requirement is not to take the total. Now my requirement is what is the difference between these two, second pair likewise up to the last pair, in order to apply the chi-square test. Again, chi-square test says summation observed frequencies minus expected frequencies whole square divided by expected frequency. That means this will be further written according to the given values and according to the newly obtained values. What are those? 32 observed frequency minus 44, it should be whole square, and divided by expected frequency, which is common for all the denominators for the forthcoming terms, plus of, that is 28 minus 44 should be whole square divided by 44, 50 minus 44 divided by 44, only numerator whole square, plus 54 minus 44 should be whole square divided by 44, 60 minus 44 should be whole square and divided by 44. In this way, if you take the simplification, then it comes to be 22. If you verify the actually calculated value, this is chi-square from the given table of values. Now, how many values are given? Totally 6 values are given. Out of 6, then the degrees of freedom you are going to write, that is 5. Means you have to refer the table of chi-square values at degrees of freedom. At degrees of freedom, that is equal to 6 minus 1, that is equal to 5, is equal to, that value is 11.07. This is table value. As I told you that, dear students, you can refer the normal distribution values for, with the heading as area under normal curve, and chi-square distribution with the degrees of freedom, like t-test and f-test also will be with the same type of title. That means here we attach with the level of significance reference, that should be at chi-square at the bottom, that is 0.05, which represents 5% level of significance. Therefore, this value is 11.07 and the calculated value of chi-square is, that means 22 is greater than 11.07. As you know that you can say your conclusion that when it is greater than this table value and beyond that range, there is 5% level of significance it comes. So that the hypothesis which we are going to propose for this as the expected number of frequencies by throwing a die for 264 times, which gives starting from 40 up to 60, may be simply rejected. That is the conclusion which you can give from this application of chi-square test. In the previous problem, individual frequency we discussed and expected frequency were different for each value, and in this problem the expected frequency is common, since those values are given as main values are given as 40 and then up to 60, and the guessing value which happens to be the common arithmetic mean. Similarly, we see in the another situation means we have to verify the theoretical distributions, as I told you in one of the previous situation, that means in the previous topic also we discussed. Now to fit the Poisson distribution to the following data and the test for its goodness of fit at level of significance as 0.05, that is using chi-square test. That means now testing the goodness of fit for certain values. Testing the goodness of fit for certain values means whatever the given values are there, you go according to the application of the equation. For example, we have theoretical distributions as 3, as you know that. First is binomial distribution, second one is Poisson distribution, and third one is normal distribution. In this data, we will see how this behaves with chi-square distribution. That is, we will verify Poisson distribution, because we have to fit Poisson distribution means we have to obtain new frequencies using Poisson distribution equation. As I told you that Poisson distribution needs the fitting of the data, which is to be multiplied by the total frequency. Of course, in this there is a typing error, that is 100 is there, it must have been 1000, because this 419, 352, 154, 56 and 19, which makes us 1000, 10 is missing. For that we will correct this mistake. Then we have to find out the arithmetic mean with the usual formula, and then that arithmetic mean must be compared as the constant of Poisson distribution, because we have two constants of Poisson distribution. One is arithmetic mean and the other one is standard deviation, which is obtained from the calculation of variance. Now we will go according to that. Now the goodness of fit for this distribution, at 0 it is 419, at 1 it is 359, 2 it is 154, 3 it is 56 and 4 it is 19. Let us calculate with using the basic equation, that is arithmetic mean, because you know that especially the symbol m in this equation, that is Poisson distribution, the symbol m represents the product of total number of observations. We call them as exhaustive cases in the probability. That is n means mutually exclusive, equally likely, and exhaustive cases, that is n, multiplied by the probability, that is p. Therefore, x bar is equal to n into p in the case of binomial distribution. But in the case of Poisson distribution, we take that arithmetic mean as m, which has been derived using the probability distribution due to Poisson analysis. Then e to the power minus m, that is m to the power r divided by r factorials, multiplied by this 1000. How these new values which we are going to get, let me explain. We have the Poisson distribution, that is PR equation, e to the power minus m, m to the power r over r factorial. That is what I was telling. This m comes by the product of n into p. This is from binomial distribution. But what do you mean by this? When once we say that it is arithmetic mean, that is m is equal to arithmetic mean, when table of values like this it is given, these are the table of values, means values of the variate and the observations. That means it is called grouped data. That is, in the basic statistics we say that class interval, this can be taken as mid value, and then this will be taken as frequency. Then, but the same thing is to be compared against input as 0, number of times that will be taken as frequency. Therefore, this must be taken as x into f divided by sigma f is there. What do you mean by this? Summation individual value of the variate multiplied by the respective frequency divided by sum of the frequencies. If you do like this, the first value is equal to 0 into 419 plus of, that means the formula says this one will be x1 f1 x2 f2 plus so on. Totally there are values up to 4 are there. That is x5 it comes, including 0 it comes to be 5, then f5 whole divided by, that is f1 plus f2 plus so on up to f5. This is the actual formula x into f over it is sigma f. That is what I am explaining. Now, each value if you take in that sense, that is x1 f1, that is 0 into 419. The next number is 1 into 352 plus so on. Likewise 4 into 19, that is 4 into 19 divided by sum of all the values, that is 419 plus 352 plus so on plus 19. This value comes to be that is 0.4049. This is for arithmetic mean, and the same thing that x bar, because this happens to be the arithmetic mean in Poisson distribution, then this is called as m in, that is Poisson distribution. That means firstly we have calculated the constant which is to be introduced sorry, in the exponential series, that is represented as Poisson distribution equation. Therefore, e to the power minus 0.4049, that is 0.4049 whole to the power r over r factorial is the construction of Poisson distribution. Is the construction of Poisson distribution. What do you mean by construction? Writing basic equation for Poisson distribution formula. Then for this, fitting the Poisson distribution, that means what we are keeping the goal in this problem is whether this Poisson distribution is going to fit or not. To fit this Poisson distribution means we multiply on both sides by the total frequency. Therefore, to fit this Poisson distribution, we multiply by total frequency on both sides. What is the total frequency? Total frequency comes to be, this is sigma f. Sigma f will be, that is total frequency. That should be 1000 if you take the total of it, that is sigma f here 1000. Like that, left side, that is n into pr is equal to n into minus 0.4049 into 0.4049 whole divided by, that is r factorial, and here in this place of capital N we put it as 1000. Now, what do you mean by r factorial? This is to the power r. And what do you mean by r factorial and this r? Where you can write this r is equal to these numbers, that is 0, 1, 2, 3, 4. Totally that is 5 values are there. For each value you calculate, put r equal to 0, and the denominator, that is 0 factorial is 1, and 1 factorial is 1, and 2 factorial is, you are going to write 2 into 1, that is 3 factorial is equal to 3 into 2 into 1, that is 6, this is 2. Then 4 factorial you are going to write, that is 4 into 3 into 2 into 1, that is 4 3s are 12, 12 2s are 24. These are the values. Then you are getting e to the power minus 0.4049. You can take this value as e to the power minus 0.4049 is equal to 1 divided by e to the power plus, you can take 14049. You see that value either from the calculator you can calculate, or table of exponential values is also available. You can simply collect that value and then you write 1 divided by how much. Then this happens to be at r is equal to 0, 1, 2, 3, 4 like that. Then you are getting the values. In place of 419 you are getting 404.9 at various values, 366. Then it should be 165.4, 49.8 and 11.3. These are the new frequencies which we obtained. That means you can easily compare at the first value, that is 419, in that place 404.9 we are getting. second value 352, we are getting through the Poisson distribution fitting that formula, we are getting 366. Likewise, the last number when you are having, that is at 19, and you are getting it as 11.3. These are the new frequencies, and those given values are the observed frequencies, and these values are called expected frequency. That means you are calculating expected frequencies using Poisson distribution formula by multiplying total frequency on both sides. Total frequency on both sides, for the purpose you have to fit this Poisson distribution to the given data. When fitting that Poisson distribution to the given data, you are getting n into PR for various values of r, that is r equal to 0, that is 404.9, at r equal to 1, that is 366, r equal to 2, 165.4, and r equal to 3, that is 49.8, and at r is equal to 4, we are getting it as 11.3. These are the new frequencies which are obtained using the given frequencies. We call them as expected frequencies. Now the rest of the part is, you have to use the equation of chi-square. What is that chi-square equation? That is summation observed frequencies minus expected frequencies whole square and whole divided by this one. So from each number, for example, the observed frequency, first one is 419, and minus the expected frequency is 404.9. This must be made whole square divided by divided by 404.9 plus so on, plus of, likewise, that is observed frequency is 19 minus 11.3, this is made as whole square and divided by, it is 11.3. What is the answer you are getting by chi-square test application equation? That is 5.78, this value. This is the actually calculated value from the formula through analytical method. You can call it as, all this procedure is analytical method. Now as usual, you have to verify the table value by looking to the degrees of freedom for the given values of the variable, that is x1 up to x5. Here degrees of freedom from the table value at 5% level of significance is 7.82, that is equal, that is table value 7.82. At what level? At 5% level of significance, means chi-square at 0.05. We write like this, that is when you write 0.05, it indicates that 5% level of significance. The value is 7.82, and the actually calculated using fitting the Poisson distribution is 5.78. When you compare these two values, 5.78 is less than 7.82. What is your conclusion? As usual, when the value comes less than the table value, and it should be in good agreement with the given type of values. That means our final conclusion for this type of situation, when table of values are given, we have to calculate first the arithmetic mean and put it as the constant of Poisson distribution and use it as the value of m and substitute in that PR equation, and then multiply by total frequency to make that one as fitting of Poisson distribution and get the new values as 404.9, first one at r equal to 0, likewise up to the last number as 11.3. Then using chi-square equation, you are getting it as 5.78, and immediately it has to be compared with the table value. Then anyway, here it is 5.78, this one less than 7.82, and it should be in good agreement. Therefore, the given values will take the fitting of Poisson distribution has to be accepted. It cannot be rejected. This is what the conclusion from chi-square test. Let us see another situation. fit a Poisson distribution to the following data and test its goodness, given that chi-square, here it is the value, it is also given, means for 5 values, just like in the previous problem, you can easily compare and then calculate new values. And first value it is 122, second value is 60, third one is 15, and fourth one is 2, and fifth value is 1. As usual, you must do that. That is, fitting of Poisson distribution equation takes multiplication on both sides by total frequency. Then for the table of values, easily you can make out, that is constant of Poisson distribution, that is m equal to n into p. It is similar to the previous data, that is n means total number of observations, and it is probability value. Here it is probability value is not given, then we go for using the table of values with the basic equation of arithmetic mean, that is sum of, that is individual values of the variate multiplied by the frequency divided by total frequency, that comes to be 1 by 2, it is 0.5. We will induct this 0.5 in the place of that m in the Poisson distribution equation, and the total frequency by adding all these values, that is 122 plus 60 plus 15 plus 2 plus 1 comes out to be 200, and this 200 has to be multiplied on both sides for this Poisson distribution equation. As a result, you are getting 121 first value, 61 second value, 15 third value, and fourth value is 3, last one is 0. Then as usual, we use Poisson distribution equation, and we were able to get this answer through the calculation as 0.025. And the table value says that is 7.815, and as usual the conclusion in this problem is similar to the previous problem. Then easily you can declare the hypothesis that the fitness using Poisson distribution may be accepted, because this value comes less than the table value. We will go to another situation. Here a set of similar coins is tossed 320 times, then the following results are obtained. Set of similar coins is tossed for 320 times, getting number of heads 0, 1, 2, 3, 4, 5, and getting head up, that means at first toss, second toss, third toss, like that. That is total comes to be like 320 here, and for 0 the frequency is 6, for 1 frequency is 27, and for 2 frequency is 72, and for 3 frequency is 112, and for 4 the frequency is 71, and for 5 frequency is 32. Test the hypothesis that the data follows binomial distribution using chi-square test. This is a new approach. In the previous two cases we discussed about the Poisson distribution application. Now we will see how this equation behaves with the help of binomial distribution in order to find the value of chi-square, and it has to be compared with the table value. Let me explain the details of in a form of binomial distribution. Then binomial distribution fitting needs the values of P, that is probability of success, by tossing a single coin one time, getting head up, what is the probability, and not getting head up, what is the probability. In the previous situation it was the Poisson distribution, and here it is binomial distribution. You have to read the statement carefully, then corresponding formula only you have to apply. In place of Poisson distribution, you do not apply binomial distribution, and vice versa. In the place of binomial distribution, don't apply the Poisson distribution, because the theory behind it is different, because the statement is different, and the value which you are going to obtain in the form of values of P and Q in binomial distribution will be like this. A set of similar coins is tossed 320 times. Yes, suppose you toss a single coin. Single coin means, this is a very first example we normally consider while defining the probability of an event to happen. An event means which we toss, yes, and getting the result head and tail will be the a total number of outcomes, that means exhaustive cases. Now, I will use the same definition, that is probability of getting head up is equal to how much? That means you are going to write by the basic definition, number of favorable cases divided by total number of outcomes. When you toss a single coin, by single coin tossing, what is the answer? As I told you that it should be with unbiased condition. It should the coin should not lie perpendicular to the ground. Coin should lie parallel to the ground, so that only on one upper surface, only one face you must see. If it is perpendicular, lying perpendicular on the ground, means it is biased condition. Then unbiased condition means the coin's face, what you are going to see, you have to see only one out of two. That means getting head by tossing single coin is number of favorable cases. It may be tail or it may be head. Getting head is 1 and total number of outcomes are 2. What are the total number of outcomes? Head and tail by tossing a single coin. If this is the value, that is probability of getting success, simply you mention it as P. Implies, what is the formula you have? P plus Q is equal to 1. Implies Q is equal to 1 minus P. Implies 1 minus 1 by 2 is equal to, it is 1 by 2. This is called probability of not getting head in a single toss. In a single toss, when you toss the coin, before it reaches the ground, in your mind you will be expecting whether I am getting head up, which is going to favor me, or which is not going to favor me. If it is going to favor me, then we will call it as probability of success. Then numerical value of such situation will be basic definition of probability. What is that? Number of favorable cases divided by total number of exhaustive cases, total number of outcomes. Total number of outcomes by tossing single coin is head and tail. That I have written as denominator as 2, and only one among two you can see, either head up or tail up. Therefore, getting head up means I will call it as a probability of success. Then I will name it as P. Not getting head means it may be tail. Then not getting head is 1 minus P. Otherwise, remaining cases, out of 2, 1 you have taken, remaining cases is 1. With this simple example, easily you can write numerical values even by guessing itself. But when you come across more number of items put together and then you are going to toss, that means more than 2 coins, 3 coins, 4 coins, like that, how many 8s you are going to support in a first tossing, second tossing, like that, those value observations will be totally different. Now by tossing a single coin like this, for the present requirement, what we do, we make use of these two values, that is P and Q, to fit the binomial distribution, and then we will find new frequencies in place of 6, 27, 72, 112, that is 71 and 32. How this equation behaves. Now, what is the binomial distribution equation? That is PR is equal to Q plus P, that is whole to the power n. Q plus P whole to the power n. Now, that n is equal to total number of trials we are going to see. Yes, what is P plus Q? 1 by 2 plus 1 by 2 whole to the power n. That is n is equal to that is 0 starts up to 5. 1, 2, 3, 4 and then 5. Now, this is PR is there, basic equation of binomial distribution. Now, to fit this distribution, to verify chi-square test, we multiply on both sides by the total frequency. To fit binomial distribution, we take n into PR is equal to capital N into Q plus P whole to the power n, that is equal to sigma F multiplied by Q plus P whole to the power n. This is equal to sigma F, we are going to write taking the total from the given value, that is 320 here, multiplied by 1 by 2 plus 1 by 2 and whole to the power, that is n. When you expand like this, in place of first value, that means n is equal to 0, n equal to 1, n equal to 2, n equal to 3, 4 and 5. You are getting the values, the new values which you are going to expect there. First number, that is 10 at n is equal to 0, and second value you are getting, that is 50 at n is equal to 1, and third value you are getting it as 100 at n is equal to next value. Similarly, next value, that is 100 you are getting, then last two values are 50 and 10. These are the values which we got them as new frequencies, but the old frequencies which are given in the statement of the problem, that is 6, 27, 72, 112, then other two values 71 and 32. You can call these values as observed frequencies. Now we are getting these values as expected frequencies. By which equation? Expected frequencies by binomial distribution. Like in previous problem we discussed as Poisson distribution. Now remaining work is as usual. We will take the help of chi-square distribution equation, that is chi-square is equal to sum of observed frequencies minus expected frequencies whole square divided by expected frequencies. That means for each pair I will do like this: 6 minus 10, it should be whole square, whole divided by 10, plus of that is 72 minus 100 should be whole square divided by 100, and 112 minus 100 whole square and divided by, that is 100, plus of 71 minus 50 whole square divided by, that is 50, and plus of 32 minus 10 should be made whole square and divided by expected frequency, and this calculation comes out to be using the chi-square test. The answer is 78.68. This answer is 78.68 using, that is chi-square test with the help of binomial distribution equation, and it is the table value which you are going to observe. Chi-square at 5% level of significance, that is for how many values it is given? 0, 1, 2, 3, 4, 5, means 6 values are there, means you are going to calculate degrees of freedom as one number less. That should be, that is at 6 values means 5, that is equal to, that value is 11.07. Then what is your conclusion by looking to the actually calculated value and the table value? Actually calculated value is 78.68 and the table value for 5% level of significance. For 5% level of significance is 11.07. It is very easy to compare, that is 78.68 is greater than 11.07. This clearly indicates by binomial distribution. By binomial distribution, we can easily reject the hypothesis that it is not going to fit with the binomial distribution in this situation, because it is highly significant and it exceeds the range, that is 5% level of significance, because 78. Easily with this value you can make out, then the hypothesis for this problem should be neglected. Let us move on to another situation using different type of calculation, then with the application to the genetics. Then genetic theory states that children having one parent of blood type A and the other type of blood type B will always be one of these three types A, AB and B, and the proportion of these three types will be on an average of 1 to 1. A report states that out of 300 children having one A parent and B parent, then such that 30% were found to be of the type A blood group, and type B, that is type AB, the product type, that is 45%, and the remainder means total is 30 plus 45, remaining is 25%. test the hypothesis by chi-square, and the observed results support the genetic theory. I'll continue this one in the next lecture. If there are any questions, you can ask, I'll answer for that.